This morning I'm going to talk to you about innovation and, oh, thank you, I really do need that. Innovation is perhaps the biggest test of a knowledge management system. We're used to capturing information, we're used to locking it down, we're used to accumulating it. We're used to creating some kinds of access to it, but innovation makes us go far beyond that. So what I'll talk to you about today is what innovation is, what the process for coming up with a new idea actually is, and then I would like to talk to you about cognitive computing, my new area of research, because I think that it solves some of the problems that our older traditional technologies cannot really address adequately. And I'll end by talking a little bit about where I think knowledge management has to go. So let me start by telling you a story. Once upon a time, there was a biologist and a physicist, and they went for a walk. And as there is their wont, the first thing they started to do was to fall into a conversation about a fairly arcane subject. In this case, it was DNA. The physicist was interested in the electrical properties of DNA. The biologist knew a fair amount about that because he was also a chemist and something of an inventor. So they talked and they walked, and then the physicist went back home, continued to ask questions, do research, etc. The biologist kept on sending information, but really went back to what he liked to do best, which was tinkering with ideas and things, because he was something of an inventor. The biologist, after several years of research, Esther Conwell, won the National Science Medal in 2010 for her work on the conductive properties of DNA and how to enhance those, because she was interested in semiconductors. So the inventor was my dad, that's the kind of thing that he enjoyed, which I think is a story of what happens when you have two innovative, open-minded people. So let's take a look at the ingredients, because I've told you this story because it's representative. First of all, you need a problem or research direction. In this case, it was semiconductors, right? But you also need opportunity. You need cross-fertilization. In this case, biology and physics, which are adjacent but certainly not congruent. You need colleagues who are, like you, interested in discussing. I have to say that in the research that I've done over the years on the process of innovation, it appears, and I didn't put it on this slide, but it's true, that innovative inventions of various kinds, discoveries, tend to be sparked by good food and a bottle of wine. It's almost a requirement. You need curiosity, you need that serendipitous encounter to create the aha moment, a happy accident. You also need information, and you need support, both in the sense of an organization willing to let you muddle around, and support in the sense of the information that is provided to you. So, what is innovation? Well, it's a lot of things, and it's a fragile flower. And I should say that quote at the bottom, in case you guys didn't catch it, was from President Obama. He said when he presented the medal to Esther Conwell that innovation is fueled by a combination of caffeine and passion, obsession, actually. So, what is it? Certainly it's a new idea. But it's rarely entirely novel. It builds on what came before, and that should be of importance to knowledge managers. The most successful innovation, the game-changing innovations, occur at the boundaries between subjects and organizations. It's a group rather than an individual effort. Developers, users, partners, and colleagues all have a part in it, because they provide not just the ideas, but also the need that spurs the innovator to solve a problem. It tends to occur at the lower levels of organizations. Those of us who are at the top of the organization, beware. It may disrupt industries or companies for good or ill, and it is both risky and rewarding. That's innovation. So what's the business case for supporting innovation? Because very often it doesn't pay off. Those of you who have R&D departments know that that's the case. First, revenue. If you are successful, it drives revenue because you are first to market. That means you are able to dominate that market, and in fact, that's what's happening with cognitive computing right now. You can attract and keep customers, build customer loyalty and market buzz, shape that market the way you want. It helps you avoid disruption and stay competitive. Helps you expand into new markets. And by creating a fertile environment for R&D, you also have a pipeline of new ideas to avoid stagnation and be bypassed by competitors, and you attract outstanding researchers who soon burn out and leave if you don't provide them with that kind of organizational support and latitude, because innovation is a fragile flower. It gets trampled very easily. My second job, which is a very long time ago, I got hired by someone who called me in after 2 weeks and said, "I heard that you were innovative, Susan. You haven't had any ideas yet." And she was right. I never had another one. For her. So what is this innovation process? Because it's quite different from what goes on in knowledge management normally. First, you have to have that idea or interest. There's no question about that. You have open discussions, wide readings, you bump into people, you talk to them in the hallways, you go out to dinner with friends who are not in your organization. And gradually you discover that there is a need which you find intriguing. This is a very individual process, even though it requires other people. So you define the problem, you eliminate some of the common ideas, you discover that other people have been there before you, and you give up and do something else. Then something interesting happens. You've taken all this information, stuffed it into your head, and you let it simmer. All of these ideas, everything that you knew, everything that you discussed. And usually what happens is that you have to stuff it into the back of your head and do something else. We had a graphic designer who was tremendously innovative. He used to go home and take a bath. I go for walks. Other people do other things. They knit, they cook. Whatever it is, they garden certainly. They have to distract the front of their brain so that the back of the brain can allow that ferment to happen. And that's great fun. But if you have too tight a deadline, if you are overly managed, and actually my daughter did research on this for her PhD, so I actually know this, you are not going to follow that elusive idea which is half-formed because you don't have the time for it. You have to meet the deadline, and it gets squashed. That's a very important thing for organizations to understand. These people who are innovators simultaneously need some direction, but they need a great deal of latitude and freedom as well. You have to explore broadly, and I'll come back to this because this is where cognitive computing and knowledge management coincide. You have to then filter and winnow and focus and rethink and iterate and go back to the beginning and start it all over again. And then finally, you have something concrete enough to develop, and off you go, maybe. So here is a standard view of the innovation process. And I believe this is only half of the process because it's linear. And thinking is not linear, especially creative thinking. So define the problem, do research on it, fine. Then you go off and develop, you commercialize it, you throw it into the marketplace, and you see what the consequences are. Big revenue, losses, whatever it is. Doesn't really look like that, though. It looks more like spaghetti. What you've got is identifying the problem by talking to customers, talking to colleagues, talking to salespeople, talking to other researchers, coming back. It's very iterative. Most of you know this. You do research and you redefine the problem. And this is also at the crux of why we need better tools. You develop what comes out of it, again, iterate, test it on the market. Look at social media, do competitive intelligence. Then you may commercialize it and see what happens after that. There are a set of information tasks which we try to support with knowledge management, with search, with text analytics. Any sort of information access and management tool is aiming to support all of these, and we don't. So the other problem with this is that we have separate tools, right, that support these. The creation tools may not be well integrated into the process. If they are, the fact is that in innovation, we're on the phone, we're sending emails, we're discussing in the hallways. We're not capturing that. So the reasons why we make decisions and change directions are poorly known and can't be modeled for the process to happen again. We are losing information that's falling off the table. We're pretty good at finding, in some ways. We're not so good at discovering what we don't know and uncovering patterns we don't know enough to look at. And yet, this is key to innovation, isn't it? Because what we want is to find out what we don't know so we can invent it. We're pretty good at analyzing information and getting better. The discussion is very often not integrated into this whole picture. And the decision-making, again, is fairly diffuse. So these are information tasks that we somehow or other need to be able to support. The role of information access and analysis tools, in this case, is to improve exploration and discovery, to introduce related information. But although we want related information, we don't want all the information in the world. And that's really hard. How do we manage to promote those happy accidents without burying the searcher? We have to somehow or other help, therefore, with the information finding process to eliminate queries, perhaps, in favor of exploration of some sort. We have to help, and this is where our traditional systems also fall down, help the user frame the question broadly, help the user understand how to ask for the information they need if they don't know they need it. Wow. We used to have intermediaries who were knowledgeable who did a lot of this, but that's not what's happening today. The tools have to help us understand and discover unexpected relationships across all sources of information, to search on a concept level rather than on keywords, because those are also limitations, to unite those multiple sources of information no matter what format they're in or where they reside, to collect and share and discuss, to enable information and people to interact in one place. And then, of course, to save us time so that we can look at enough information in order to have those ideas. I believe strongly that the set of tools that are starting to emerge over the last couple of years are key to supporting these expanded roles for knowledge management. And cognitive systems, to me, seem like the next logical step. So as an analyst, I've been watching the markets develop all kinds of tools: business intelligence, search, text analytics, graphics of various kinds, reporting tools, creation tools, drawing tools. And they all solve a piece of the problem. And we used to call it Sneakernet. I don't know if all of you remember that. The Sneakernet that goes on in the creative process, in the innovation process, is overwhelming, and it's a tremendous waste of time. And you're constantly rummaging, certainly I am, back through stuff that you did 10 years ago because, you know, you did it already. There's this niggling feeling. And in fact, when Jane asked me to talk about innovation, I had to go back to research I did 10 years ago because I knew I'd done something about this, but I really didn't remember where it was. It was really hard to find it. Desktop search is terrible. And yet, you know, there it was in the back of my head. So anyway, cognitive computing is going to bring us another step closer to some of these problems. What is cognitive computing? Well, as Jane said, I brought together a bunch of 14 or 15 people last year to try to define it before marketplace hype completely screwed up any idea of what it was. I don't know if we're succeeding or not. I hope that our consortium that we're launching will help to inject a note of reality into this discussion. And if you're interested in that, please contact me. But what are these problems that cognitive computing attacks? They're the ones that we have left on the table because we can't put them into neat rows and columns. They're ambiguous. They're unpredictable. They're very human. There's a lot of conflicting data. There's no right and wrong. Rather, there is best, better, not such a good idea, but maybe. They require exploration, not searching. You just have to keep poking at it and shifting things around. I don't know about you, but when I'm doing the beginning of a project, I'm jotting down ideas and I'm kind of arranging them on a large table because sometimes they fit together one way and sometimes they fit together another. You need to uncover patterns and surprises, and computers are very good at this because they don't get embarrassed by wrong ideas. And although they will have the biases that they get from their programmers, they're still going to have different ones from the ones that you have. So the situation is shifting as well. As we learn more, we change our focus and our goals. Going back and asking the same question, which we often do, but hoping for different results because we've already learned that stuff, is not so easy in the stateless systems of today. If you go to Google and ask the same question, you're going to get, well, not the same answers, but similar answers, right? But in fact, if you were looking for pictures of Java because you're planning your vacation today, and 2 months from now you want flights, the system won't know your progress and your decisions. How do we make that system into a partner so that it keeps track of who we are and what we want to know at this time? It gives best answers based on who you are, where you are, what you know, what you want to know, when you want to know it. It is very individually focused. And it's aimed at problem solving beyond information gathering. It gives recommendations based on who you are. So I want to give you a couple of examples because context, we have found, is one of the differentiators of this kind of system. How many of you watched Watson win Jeopardy? or have seen it on YouTube. Just a few, that's interesting. In 2011, IBM designed a computer that actually won Jeopardy against the previous champions, the human champions. And that was the beginning of cognitive computing. You ought to take a look at it on YouTube. All of those videos are up. For me, as a person who has been in the chaotic world of search and text analytics all my life, it was a validation that the kinds of things that we do, the search index as opposed to the database, were actually really useful for some very complex problem solving. That was the beginning. Here's another context, though. This is a patient. And the emphasis on who, what, where, when you are is one of the differentiators for cognitive computing. We all need slightly different slants on the same question. So in this case, we have a patient who has a disease, and his genetic makeup, his age, his history, that he was a smoker, that he has certain allergies, et cetera, where he is, what kind of access he has to medical care, and then access to enormous amounts of information, especially in healthcare, and possible treatments and confidence scores. How does this change healthcare? Because this is life and death. So today, standard healthcare, you have a disease, you have a particular kind of tumor, there are treatment guidelines, doesn't matter if you are black, white, female, male, young, old, whatever. That's how you treat it. That's not the way it needs to work. If instead you have all that information, more information than any doctor can amass in his head, and you've ingested it, and you can start to match that person as a query, actually, if you think about it, against that information, and all of the drug side effects and all of the stuff we've known about clinical trials, you come up with maybe 2 or 3 treatments. Maybe the system says, have you considered that if you did this test, we would have more confidence in recommending? It's dialogue now. It's a dialogue that supports the doctor and the patient in their decision on a treatment. And that's the kind of medical care I want. So that's another kind of context. You'll notice that the context keeps changing. Suppose you're an investor. In that case, the context is the portfolio, the personality. Are you conservative? Are you a risk taker? How old are you? Do you want a lot of data, or do you just want to be told what to invest in? Are you an influencer? How old are you? What's your previous investment history? What are the market trends? What is your investment strategy? All of those things need to be taken into account. That's what human investment advisors do, but they're not all knowing. Starting with the evidence, the information, and then being able to make a better judgment instead of a gut intuitive decision is a very good idea, especially if it's your money. Here's another one I find fascinating. This is from Customer Matrix. They have a sales application, sits on top of Salesforce. They do a lot of this. They look at who the salesperson is, they look at who the manager is, who the strategist is for the company, and give different answers. But the thing that I am fascinated by with this one is that they also have ingested your business goals and your business strategy, and they will make recommendations according to the usefulness of approaching one prospect or another for acquisition, for sales, whatever, based on how a positive outcome will influence the business of the entire company, as opposed to just that salesperson's commissions. Not a bad idea. This one is from Expert System, and I'm just showing you that this can be very familiar. It can look like a dashboard that you're used to. They do the usual text analytics things, they extract sentiment, and this is all about a cat that was a popular resident at one of the train stations, but they extract things like sadness and give perhaps people who are writing news, for instance, a very good idea by comparing the number of hits, the number of readers, the number of tweets, etc., against the kinds of extractions they've done already in order to understand better what readers are looking for. So this is kind of a building block, and the context is this particular event. All right, what is cognitive computing? It's meaning-based. One of the award winners said there's a certain amount of natural language involved. That's absolutely true. It's probabilistic, it's not deterministic, and this drives a lot of IT people crazy because they expect the answer, not some possible answers. It's very iterative, it's conversational, it's contextual. This is very interesting. It learns and adapts, not only to you, but to everybody else using the system, and it keeps getting smarter. Machine learning is a requirement. It usually has a big data knowledge base. That means that if you have lots of data, even though somebody is living in the long tail in terms of his needs, his profile, whatever, you still have enough data, enough evidence to be able to understand that individual. You're not just aiming your business at the center of the bell-shaped curve. Analytics are built in of various kinds, and the technologies are highly integrated. It's not services-oriented architecture. That's also important. They influence each other. So what do these systems do? They analyze big data. They understand human language on multiple levels. They uncover relationships across sources, and that is very difficult. It's a whole nother discussion. They understand and filter by context. They find patterns in the data that you didn't know existed. They find the black swans among the white swans, the surprises. This is so valuable to competitive organizations, to governments, to individuals. And they learn from new information and new interactions. As you use the system, it gets better. We hope. Here are some examples just to show you what the next leap is. So we can find drugs in a database of drugs and even side effects of drugs that are useful for controlling diabetes. But what's the best drug in this circumstance for this patient? We're looking for best, not just a list. Who's funding this terrorist organization and how are the funds delivered? This is also a really useful question and one we've been asking for a long time. But how big a threat is this organization? Can you make a recommendation about the level at which you need to react to what's going on? Can I identify the most risky product or customer problems? Because it's very difficult to know what to pay attention to in the world of information overload and big data. Can we get some help in this? And which company is the most promising M&A target? Not just an, but the most promising. That's the kind of thing that you would want a bunch of humans to sit down and discuss, but there's an awful lot of information to wade through. Can we make the system a partner, make some recommendations, and then sit down and discuss it? We'll probably find stuff that we didn't know. All right, what it isn't. It's more than big data or AI. And there are books coming out that say if it's machine learning, it's cognitive. I disagree, and so did our group of experts. It's not robotics, it's not drones, it's not humanoids, it's not entirely autonomous. At least that's what we feel right now. It is not the singularity, and it's not a replacement for humans. It's an aid. It's another tool for us so that we can begin to understand our world and our problems and solve them more effectively. I'm going to very quickly talk about what a cognitive system looks like. This is the best cognitive system we know. Your senses take in clues from all over, and then they discuss what they have found with other people in innovation. Both of those are really important, but those synapses, those connections, are something which is very hard to mimic. Here's a traditional information system that you're all familiar with. It's very linear, sequential. You ask a question, it goes into the index, you've indexed all the documents get matched to the question, usually with the terms in the question, and out spits the information, and then you make a decision. The problem is that there really isn't enough interaction. It's almost as if the designers felt that people couldn't be trusted, and therefore we had to have a wall between what we had in our heads and what they had in the system. Let's move on to a cognitive system. Here are the pieces now. I say there's a question, but in fact it's a problem statement or exploration, and there's a great deal of iteration. One of the things that was a huge breakthrough for Watson was question analysis. Before they ever threw the question into the system, they defined what kind of question it was and what kind of answer might be required. And they had hundreds of different question types for Jeopardy. This is what people do too, right? If I say, how do I get to the airport? You're not going to tell me stuff about President Reagan because you're a person and you know what my context is, right? By analyzing who, what, where, when types of questions, by extracting the elements of those questions, we are already ahead. But more than that, when we ask a query, we usually focus it down and make it as specific as possible. We have to because we're going to get garbage otherwise. But that's not what we really want to do. At this point, especially in innovation, we want to explore, right? Well, if we're exploring, then what we want to do is expand and create hypotheses. Use each of those hypotheses to collect evidence to support or to deny that particular hypothesis. That's what these systems do, particularly the Watson-like ones. All right, so we're sending an expanded query, if you will, or problem statement to a system which has done the orchestration of how to answer that particular kind of question. And different kinds of questions, as you well know, are more effectively answered by different combinations of tools. And you usually have multiple tools. So you may have 4 categorizers in one of these systems, or 10. And how that question is answered depends on the type of question and which array of categorizers is most useful, which one needs to have priority. This is fancy stuff, right? So after we have done the question analysis and expansion, it goes into a cognitive processor, which is, it's analogous somewhat to the index, which hits the information store, does the similarity matching, and out comes perhaps a huge pile of information. But certainly confidence scores have been assigned. Evidence has either proven or disproven some of the hypotheses. Perhaps they've been combined. Lots of stuff going on in there. There are sometimes voting algorithms to help with the confidence scoring. For Jeopardy, there was game theory, which is why you got such crazy wagers like, I'll wager $727 on this question, which is not a very human kind of thing to do. But Watson knew that it could afford to lose $727, but not $728 apparently. Anyway, out come the data set. And the filters are the who, what, where, when of who the person is, where they are in the task, what they've asked before, what other people have also asked about this, and they are filtered down and sent to the exploration loop. The exploration loop is a set of tools that help visualize and analyze the information. Now, the interesting thing is that at each step, what the system has done in terms of interaction, question answering, filtering, data sets that have been analyzed, gets thrown back into that cognitive processor, making it smarter, more dynamic. And that's important too, because it follows you along in the process. In order to accomplish this, because computers don't have your senses, we have an array of technologies that look pretty familiar to all of you in this room. They work together. Facial recognition, rich media understanding, content intelligence services, machine learning certainly, real-time voice translation, speech recognition, taxonomies. Any tool that's useful to solve a particular kind of problem needs to be bundled into these systems. And right now, at the dawn of the cognitive age, we're still trying to figure out what configurations work best for which problems. That's the kind of research that I'm working on right now, because people keep asking me, what kind of problem is this good for, and how, what do I look at? What are the tools? So, what are the elements of innovation? People, collaboration tools, access tools, information, certainly. More and more information of different types. And a work environment that is designed for cross-fertilization. What kills innovation? Lack of organizational support, party line thinking. No time to think. Too rigid innovation systems. Lack of encouragement of innovation. Poor or limited information and information access. And of course, information overload. So we want lots of information, but we don't want too much. Boy, that's a tall order for knowledge management. So can we reimagine knowledge management? What can we do to give us a sort of informed serendipity? How do we do this? I believe that cognitive computing can help with this, but there are some changes we need to make in our systems, in our tools, but also in our thinking. I believe strongly, to bring us back to that DNA metaphor, that we need to get away from structures in some cases. They're useful, but not only do we need to capture information and conserve it, we also need to cut it loose. We need to allow the information bits that are attached to those taxonomies, that are contained in those cells of the databases, that are in the documents and the text analytics systems, categorized to within an inch of their lives. Let them loose. Let them float around, bump into each other, and give innovators the opportunity to create their own information soup, if you will, to explore without forcing them into the structures that we have created. Because what they want to do is to find the unexpected. By creating schemas and taxonomies, we are giving them what we expect in terms of how information works. So this is a tall order for knowledge management, and I leave it with you as a challenge and a question. Thank you very much.